Oh, all right. So this is the third lesson. Today we have looked at global air circulation, which is the foundation for both for better comprehension of wind latitudes, tropical cyclones, and also subtropical anticyclones. So this is a new lesson now. It's about tropical cyclones. I think I have already explained that obviously tropical cyclone, it's low pressure system. So from here, what I'm going to start with is identifying it from our global air circulation diagram. I think just as I'm going to do first. So you can see here we have got the ITCZ, which is a low pressure belt. This is a low pressure belt. This is where we have got our ITCZ, which is our intertropical convergence zone. We have also said that it is also known as the doldrum. That is where we've got our low pressure at 0 degrees latitude. That is where our equator is. So in order for you to have a better comprehension of tropical cyclones, the first thing that we need to do is to look at the alternative names. It's known as tropical cyclones. This is because of where they originate from, but the first thing that we need to know is what are the alternative names that are also used for tropical cyclones. In the northern Atlantic, they are known as hurricanes. In the northern Atlantic, they are known as hurricanes. In the North Pacific, part of Asia is known as the typhoons. I think you need also to be aware of these two terms. These are the alternative names for tropical cyclones, especially in the North Atlantic, the hurricane, typhoons, North Pacific, where we are now, we are calling them as a tropical cyclone, but especially on the part of our southern hemisphere. Okay, where do they develop? Okay, so the first thing is they develop in the ITCZ. This is your intertropical convergence zone. They develop in the ITZ, which is called the intertropical convergence zone. This is where they develop. Okay, outside the 5 degrees north and south of the equator, which means here there is no Coriolis force. Remember, we said wind is deflected to the right in the northern hemisphere and the southern hemisphere to the left. So they originate outside 5 degrees north and 5 degrees south. This is where the tropical cyclones originate from. This is where they develop from, 5 degrees north and south of the equator, because of the absence of Coriolis force between 0 to 5 and 0 to 5 degrees north and south of the equator. So they originate outside the 5 degrees north and south of the equator. What else? Because of the absence of the Coriolis force. Remember when we talked about Coriolis force earlier on, when I was explaining on global air circulation, I said wind, especially in the northern hemisphere, is deflected to the right, whereas the wind also in the southern hemisphere is deflected to the left. It is because of the absence of Coriolis force within 0 to 5 and 0 to 5 degrees north and south of the equator. That results in our tropical cyclone starting to develop from 5 degrees north and south. So here there is no Coriolis force. Okay. There's also intense low pressure. Remember when I was explaining the characteristics of the low pressure system, especially part of our low pressure belt, the ITCZ, there's warm air. That warm air is forced to rise. As it is rising, that's how a low pressure system is created. As it is rising, it cools, reaches the condensation level, then other processes takes place as well. So there's intense low pressure storm that is within this range, that is from 5 degrees north and 5 degrees south. Not at 0 because there's absence of Coriolis force. The tropical cyclones are also named alphabetically. In the season they occur, which means in that season, the one that is starting, let's say it's A, it's Anna, tropical cyclone Anna, then maybe the next one, tropical Betty, the next one, tropical whatever it is. But the names that are given to this tropical cyclone, they have something to do with the areas where they develop as well. Then also, the main source of energy is latent heat. What do we mean by that? When warm air, since we said that low pressure system is associated with warm air, when it forced to rise, Okay, it rises, it cools. The heat that is released when it cools or before, when the process of condensation takes place, this is where the latent heat is produced. And this latent heat that is produced, it actually gives more energy to the tropical cyclone. That's why you see in most cases where it takes place, it's associated with unstable weather conditions. So the latent heat that is released, it also gives energy to the tropical cyclone in terms of its movement. It's okay in the tropical regions over warm oceans. Normally where there's warm oceans, what happens? Warm air is forced to rise. There's a lot of evaporation that takes place, which means the rising air has got a lot of moisture. The rising air has got a lot of moisture. And when the rising air cools, it's cooled adiabatically, which means for every increase of 1,000 meters, the temperature drops by about 6 to 6.5 degrees Celsius. That's why we say, when we say it is adiabatically cooled. When it reaches the condensation level, clouds form, especially clouds of vertical extent like cumulonimbus that are associated with heavy rainfall and also strong winds and also heavy storm. That's how we end up having floods where we've got the tropical cyclones. And during that time, the latent heat that is released during the process of condensation is what also aids to the energy of the moving tropical cyclone. They move from east to west. I think if you can check here, from 5 degrees north and 5 degrees south, you can see from here, this is where they are moving from east. This is where, remember, this is where we have got the easterlies. This is where we have got the easterlies. From here, 5 degrees north to 30 degrees north, 5 degrees south to 5 degrees south. This is the region where we have got the easterlies. If I'm to take you back to your grade 11, we're talking about the Hadley cell, okay? That's where we have got the Hadley cell. So here from 5 degrees south to 5 degrees north, okay? This is where it's moving from this towards this, okay? That's where we are saying it's moving from, from east to west. That's why we're saying it's move from east to west. Okay, in the tropical cyclones, where warm oceans, it's moved from east to west. Okay, you can see from here up to there. It's coming from this. This is where we have got the easterly. So it's moving from east and moving towards the west. Okay, warm temperatures are supposed to be at least 26.5 degrees Celsius. These are some of the conditions when it comes to the tropical cyclones. So you can see from the diagram there I've drawn. It's unfortunate that I've got a small board. But the alternative names, if I'm to go back, is hurricane in the northern Atlantic, typhoon in the North Pacific. Where do they develop? At ITCZ, but outside 5 degrees north and south of the equator. So which means here the absence of Coriolis force. There is no deflection of wind within the low pressure belt that is at 0 degrees. At 0 degrees, okay, there is no deflection of wind either to the right in the northern, left in the southern hemisphere. That's why they develop from 5 degrees south and 5 degrees north. That's when you start to see the impact of the development of tropical cyclones from 5 degrees south and 5 degrees north because of the absence of Coriolis force. It creates also intense low pressure. Remember, there's warm air that is there, which is forced to rise. As it rises, it cools, condenses, form clouds of vertical extent like cumulonimbus clouds. They are heavy, rain that is associated with the tropical cyclones, the storms as well, and so on and so on. So this is part of the introduction. I'm going to take you, I've got some notes that I'm also going to refer to. I think you can see here we are looking at the stages of formation. This is very important when you're talking about the stages of formation. What is it that is important? You should familiarize yourself with the stages of formation because it goes through stages. There's formative stage, there is immature stage, we have got the maturity stage, and also the dissipating stage. I'll just take you through all the stages. The first one, of course, this is where it's still in its infancy, it's forming. Okay. In the formative stage, the cyclone has a very strong updrafts and low pressure intensifies. The cyclone is not very large yet and there is no clear eye. The wind starts spiraling, pressure generally above 100 millibars, which means when you're looking at the pressure here, you can see in the middle, it's 102. Okay, this is a low pressure belt, which means the pressure is low in the middle and it increases and it goes outwards. You can see here, there's 106 MB, or hectopascals, whichever you call it, okay? So you can see that there is high pressure. It's still above 1,000 in the formative stage. That's what you need to take note of. In the formative stage, it's above 100. Then when it moves now to immature stage, you can see now the pressure is dropping. The pressure is dropped to below 1000. So one thing you can notice in as far as the stages are concerned is the changes or the trends in terms of the change of your pressure. Okay, in the formative stage is above 1000. Then the immature stage, the very strong updraws of air increases, the temperature increases due to the release of latent heat. Ice starts to form, pressure in the center drops to below. So the pressure at the center you can see now is 902 millibars. It has dropped from 1000. That is the immature stage. The most important that is usually assessed now, is your mature stage. There is a lot of things that you should take note of. What do I mean by that? I'll just read through and also try to explain a bit. The pressure gradient is very strong. Remember, when our if you look at our isobars, which is the line that shows areas of equal pressure, they are very close to each other. It resembles, or it shows that there is steeper pressure gradient, which means that they are strong winds. The calm speeds reach hurricane strength. The calm, clear eye is well developed, and the air pressure is well below. Here we have said it's above, here it's below. Now here it's well below. You can see it's around 956. It's well below. Okay. The forward left quadrant, we are referring to this. Forward left quadrant is the most destructive as the intense winds in the cyclone combines with the force of the entire cyclone. The cyclone can cover a distance of about 300 kilometers from the eye. The cyclone moves in the southwesterly direction from the equator. The low pressure and the fast wind over the ocean moves cause the storm edge bulge, which leads to the further flooding of the coastal areas hit by the cyclone. You can see in terms of its movement, this is very important. You should know identifying the left quadrant and also the effect that it has on the cyclone. Remember, with the release of the latent heat, which means it's giving the tropical cyclone more energy. This is what makes it more destructive. It is also associated with floods, and you can see as it goes now, as it will be moving, as it reaches the coastal region, it can also result in the destruction of vegetation. Mostly we are talking about the natural vegetation, displacement of wildlife. We're looking at land degradation in general. Then when it is dissipating now, which means now it has reached the land. It has reached the land due to frictional drag now. It has reached the land. It has lost most of its power. It's no longer in the ocean. When the tropical cyclone moves over land, the wind is slowed down by friction and there is less evaporation, which means now in terms of the moisture that is available, now it has been lessened. Why? Because it is now reaching the land. The source of moisture now, since it has moved from the tropics, where normally we have got the warm ocean, now it has lost most of its moisture. The tropical cyclone moves into cooler subtropical high areas and the air pressure increases. The weather clears up and pressure increases, okay? I want to take you to the diagram now. I want to take you back to the diagram. Okay, what is it that we are trying to say? As you can see, this is where our tropical cyclone is originating or emanating from, 5 degrees north, 5 degrees south. So we are saying that it moves from east to west. As you can see the movement that is taking place as it is moving. You remember warm air, it is within the tropics. These are warm ocean. Warm air is forced to rise. As it rises, it cools, condenses. As it condenses, there is latent heat that is produced. That latent heat, it actually gives more energy. It makes the cyclone to be more destructive because there's more energy that is derived from the release of latent heat. But now as it reaches the 30 degrees north, remember we said that when it reaches here now, it has lost most of its moisture, and also due to frictional drag, it has reached the land. Hence, the amount of moisture has been released. Now, the air is now cool. So when it reaches there, that's where when it reaches the 30 degrees south and north, now there's creation of high pressure. There's high pressure because there's low, because it has lost most of its moisture content. The temperature has dropped as well when it reaches now the 30 degrees north and south. That's why even if you are to see where most of our deserts are located, you can see it's within this region because it's a region of high pressure where the warm air that is descending now, that is sinking, has lost moisture, is now cold. It results in clear skies. So from here it moves from 5 degrees north and south, then it moves in a southwesterly. What do we mean by when we say the southwesterly? It's coming from the northeast and moving towards the southwesterly direction, which means when you're looking at cardinal points, you have got something like this. This is your east, this is your south. It's moving from here. Sorry. This is your west. So southwesterly, which means it's moving from northeast up towards southwestern direction. That's what we mean. When it reaches the 30 degrees south now just because it has reached the land due to frictional drag, the energy is no longer released as the one that we have when it started. Why? Because they just lost a lot of moisture. The air, the temperature now is dropped. It's now cold. Hence, it creates clear skies. Now it has reached land. Then this is right now is reaching the coast or overland. Hence, it has lost a lot of energy. But these areas usually experience floods just because of the tropical cyclones. And some of the effects that we'll have. Remember, these are tropical cyclones. These are tropical cyclones. Okay. There are also effects that are felt in as far as tropical cyclones are concerned. There's a part that I've skipped as well. I need to emphasize. I think let's go back to my notes. There's an area that I've skipped. I need to emphasize the area that I've skipped. It covers the conditions that are necessary for the formation. It's a lot of mixed up the way I'm putting it now, but I think you won't be confused. Condition necessary for the formation. What do you have there? You have got large sea surface with temperature higher than 26.5 degrees Celsius. This is usually assessed. Then the presence of Coriolis force enough to create a cyclone vortex. That's what is also important before it starts. Then small variations in the vertical wind speed. Obviously, you remember that we need high wind speed so that the tropical cyclones can be able to move from where it starts up to when it will be moving in that southwesterly direction. Then the pre-existing weak low pressure area and low pressure cyclone circulation upper, divergence above sea level system, the good source of latent heat, we have talked about that, and also the calm condition. These are some of the conditions that are necessary for the formation of the tropical cyclone. Some of the conditions that are associated with the tropical cyclone, I think you can see from there. Obviously, the strong winds that is there. You can also see that there are also floods that are associated with the tropical cyclones. So floods, the floods, and also unstable weather conditions. So if you look at all those conditions, you find that they are destructive in nature. When there are floods, obviously the environment is affected in a way. It has environmental impacts, social, and also economic impacts. You can see in terms of the environment, mostly fauna and flora, that is your animals, and also your plants are destroyed. There is soil erosion that takes place, especially in the coastal regions. Some of the houses are washed away. If there's cultivated land also, is also affected in a negative way. So these are some of the challenges that we have in as far as the tropical cyclone is concerned. There's something that I need to add on as well. Yes, please. Okay, so this is an example of a cross-section of a tropical cyclone. I think this is very important. This is from a June 2019 paper. You can see the question reads, refer to the Fig 1.1 showing a cross-section of the tropical cyclone. Choose the correct words from those given in brackets to make the statements true. Write only the words next to the question numbers 1.1.1 to 1.1.7 in the answer book. So you can have questions of this nature. The good thing is we have got the question here, then we also have the marking guideline there just to get our answer. Okay, cloud A is a cumulus or cumulonimbus cloud. I think you can look here, you can see what you have. This is cloud A. This is a cloud of vertical extent. Remember, the clouds that bearing that results in a heavy rainfall. Okay, so if you look at the clouds between the two options that is given, it's a cumulonimbus cloud. This is where we have got our eye here, which has got mostly calm conditions. So I'm going to explain as I also give the answers. Cloud A is a cumulonimbus clouds. So cloud A is a cumulonimbus clouds. This is what results in heavy rainfall. Then number 2, it reads, the updrafts B are caused by, updrafts B, you can see this is rising air. What is causing it? The rising air. What is causing it? It is caused by convection. You can see it is caused by convection, not advection. This is convection. This is the updraft at B, the rising air. That is the updraft. What is causing that? It is caused by convection, not advection. Then area C is named You can see where you have got our area C. This is our I, where in most cases they are calm conditions, calm condition. You can see this is where we have got our C. This is called the I. Then we have got the atmospheric condition experience at T is stable, because usually we have got cold air that is descending. We have got cold air that is descending. Remember where we have got the cold air, as the air is rising, it reaches, maybe let me say it off to 15 kilometers before it reaches the tropopause. Now it has lost most of its moisture. It's now cold. Now it's descending. So that forms part of our C. It forms in stable. It's stable conditions because there's no formation of clouds. There are clear skies. That's why we say it's stable. The D indicates the area of convergence. You can see your D convergence. Why are we saying convergence? You can see these arrows, this one coming from this side, the other one coming from this side. When they meet, that's why we say they are converging. They are meeting there, converging, which means there's warm air, which is forced to rise, as you can see by the rising updrafts there. You can see by the rising updrafts at B, okay? That's now they have moved close towards each other. I will take this as our ITCZ, where we have got warm air rising. So the updrafts you can see, which results in the formation of clouds of vertical extent, that is your cumulonimbus clouds. Then E will experience, E, when you look at E, where is our E? There is our E. You can see with the rainfall. Obviously, is going to experience thunderstorms. You can see because of the cumulonimbus clouds. It's going to experience thunderstorms. Then ocean C is finally, where's your ocean C? There's your ocean C. You can see usually, ocean F, usually the tropical cyclones, where do they develop? Usually in tropical regions where we have got warm oceans. That's why we end up having the ocean C being warm, because that warm air, when it converges, it's warm and it has got a lot of moisture, is forced to rise. As it rises, clouds are formed, usually cumulonimbus clouds, which are clouds of vertical extent associated, which are rain bearing. Then we have thunderstorms, as already explained. So you need also to be aware of the cross section of the tropical cyclone. You also need to be of the cross section of the tropical cyclone, being able to define it, being able also to explain it. You can see from the surface, you can see there is convergence. I'll take this as our ITCZ, which means they are moving towards each other. Okay, the explanation that I've already given, they're moving toward each other. These arrows, as you can see, it's warm, it's within the tropics, and as it moves towards each other, it's forced to rise. Warm air by its nature is very light, it's dense, since it's forced to rise. As it is rising, it cools and condenses, but before it reaches, you can see where it reaches now, the 30 degrees north and south of the equator, it has lost most of its moisture. Now it's cold and has lost most of its moisture. So in the lower atmosphere or on the Earth's surface, what happens? It converges. In the upper atmosphere, it diverges. You can see with the arrows, they're moving towards that side. Why? Because it's now cold, it has lost most of its moisture, it diverges, then it sinks, and you can see it sinks, then it converges again on the Earth's surface. So you take this as your subtropical at the top, where it has reached the 30 degrees north or 30 degrees south. Then when it reaches that point, it lost most of its moisture, it has also dropped in terms of temperature. What happens? It sinks, it diverges, moving away from each other, then it sinks. So it converges, warm air is forced to rise, it goes up. When it goes up in the upper atmosphere, it diverges, it's now cold, lost most of its moisture, then it sinks. Then on the surface, what happens? It converges, rises, warm, cools, cumulonimbus clouds are formed. In the upper atmosphere, it diverges, it sinks again. So this is what happened, and this is also how you explain the cross-section of the tropical cyclone. Identify your I. Where do you have your warm air rising, your updrafts? Where do you have your clouds that are rain-bearing, that results in clouds? I think you can see as indicated by E there. This is a typical question that you find in your exam or in your test. Thank you.